Hello my dear students, how have you been? I hope you are doing great and having a wonderful time with mathematics. ACC Mumbai welcomes you once again to an interesting and exciting video of the exercise 5.1 exclusively question number 6 and 7. Before we proceed, do remember to subscribe to my channel by clicking on this link and opting for the bell button so that you have the regular updates given to you. Please ensure to watch the video till the end so that you get a fantastic command to the solutions of question number 6 and 7 for exercise 5.1. Without much ado, let's continue. Look at the board. We see that this is a sum. We have a sum of 1 square, 2 square, plus 2 square equal to 3 square. So if you observe, this is a pattern. When I observe this pattern, there are two blanks over here and here. Let us see, what does this mean? If you observe, here you have to be very observant. We have to see a relation between numbers which gives us the number which is on the right hand side. So when we observe, 1 square plus 2 square plus 2 square is equal to 3 squares. Then 2 squared plus 3 squared plus 6 squared equals 7 squared. Third question. 3 squared plus 4 squared plus 12 squared equals 13 squared. So if you have a good look at the first three questions, which are the sums, these are the sum of squares of the numbers. 1 square plus 2 square plus 2 square plus 3 square. Please focus your eyes on the third digit, which is 2, and the first two digits, which are 1 and 2. So let us name this as first digit, second digit, third digit and the fourth digit. Alright, so we shall observe the third digit and try to find out a relation between third digit and the first and second. So if you have a good observance over this, you will see 1 and 2, when they are getting multiplied with each other, we get the third number. Do we have the similar pattern? For the second number, I see 2 and 3. When you multiply them, you get the third number. Isn't 2 times 3 equal to 6? Isn't 1 times 2 is 2? So I see 2 into 3, which is 3 times 2 is 6. 2 times 1 is 2. Now look at the third question. 4 times 3. If I multiply these two, 3 into 4, which is 4 times 3 equals 12. So I will multiply this. Don't we see that 3 into 12 is 3 into 4, I'm sorry. 3 into 4 is 12. So when we see the relation of these three numbers, 2 times 1 is 2, 3 times 2 is 6 and 4 times 3 is 12. Accordingly, if you see the pattern, obviously you would certainly proudly say that yes sir, it's 5 times 4 is 20. Go for it. We see that this number is 20. I hope this is absolutely clear to you. Once again, if you look at the pattern, 2, 6, 12 and 20. These digits which are in the third digit of the left hand side, they are derived by multiplying the first digit and the second digit. And you can see the first number and the second number. You get the third number. 1 into 2 is 2. 2 into 3 is 6. And 3 into 4 is 12. Similarly, we got 4 into 5 is 20. Next question. If you look at this, we have the product with us. We have the product as 30. However, to get the product, one of the factors is 5. Can you please tell me what would be the number here? What would you multiply with 5 to get 6? We know 6 times 5 is 30. So please carry on and put the number 6 over here. 5 into 6 is 30. 4 into 5 is 20. There you go. This was the second question. This is the third blank. The second blank and the first blank and the second blank. We have the third blank. Third blank is again the square. So obviously obviously I will go ahead and multiply 6 and 7 with each other. When I say 7 times 6 is 42. Let's continue. 4 and 2. There you go. We have the first blank which was 20. I have the second blank which was 6. And the third blank is 42. So this was the pattern we observed of the left hand side. Let's come to the right hand side. When we look at the right hand side, we have the last question which is having a blank. But let us see the pattern. The pattern over here is 1 square plus 2 square plus 2 square is 3 square. Let us find out the relation between the right hand side number with the other number which is the third digit. If you plainly look at it, isn't it the extremely the next digit after 2, like natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 is the number that is preceding the 1. I see 3 is preceding 2. 6 is preceding 7 and this is 7. Here I will say 3 is succeeding 2. Look at the pattern. We got this 2. This 2 was derived by the multiplication of 2 and 1. But the number 3 which is on the right hand side, this is just derived by adding 1 to 2. So 2 plus 1 becomes 3. 6 plus 1 is 7. 2 plus 1 is 30. If I observe 6 to 7, I add 1. 2 plus 1, I add 1. What do I do over here? 12 into 13, again plus 1. The next number after 12 is 13. Similarly, 20, the next number is 21. I'm adding a 30. The next number is 31. Last but not the least, the last number on the right hand side of the number 42 would be 43 square. So I carry on over here and I say with confidence, I can say this is 43 square. There you go. So we have this pattern absolutely on the screen, on this wall. We see 1 square plus 2 square plus 2 square equals 3 square. To look at the pattern, 1, 2, 3, 4, 5, 6. We have 6 equations solved in totality. This is the 6th question of exercise 5. We have the question number 7, 1, 2, 3 on the whiteboard. Have a look at it. We have 7th question says that we have the sum of odd numbers 1, 3, 5, 7, 9. These 5 odd numbers are being added. When we say they are added, the second question says we have extended the number 9 till 19. We have added some numbers. And the third question says 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23 is extended till 23. However, before we add them, we do not need to add them physically with our hand, with a paper and pen, since we have a formula. We have a formula to add these numbers which says the sum of n odd numbers is nothing but n square. So if there are 5 odd numbers starting from 1, we will have the odd number square as 5 square. Won't that be 25? There you go. So I see 1, 3, 5, 7, 9. There are the first 5 odd numbers in the number system, which says, the question says addition of these 5 numbers, do not add them, since we have the formula which says sum of first n odd numbers is n square. So what will I do? I will say this is 5 square. And if you observe, 5 square is nothing but 25. There you go. This is your answer. 25 is your answer for the sum of the first series. We have the second series. Second series says 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, 15, 17 and 19. Let's count them once again. We had 5 numbers till 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. we have 5 more odd numbers which have been added. What do? Let's see, 5 plus 5 becomes 10. Ideally, the sum of these odd numbers would be n square. In our case, this number 10 is serving as the number n. So if I say this would be nothing but 10 square. And we know 10 squared is 100. So there you go. You say the answer is 100. This is your final answer for the second question. The sum of the first 10 odd numbers is 100. Let's go for the last question of the seventh question. We have the series. The series is again the odd number series which have been added, and you will observe the addition is till 23. Since we had 10 numbers till 19, 11 and 22 to 11 and 23, we have the third question which says it is the sum. We have the third question which says 1 plus 3 plus 5 plus 7 plus 9, 11, 13, 15, 17, 19, 21 and 23. There you go. We had 10 odd numbers till 19. So we have the 11th odd number and the 12th odd number which is added, which means the number n, the value for the letter n has changed from 10 to 12. So what do? We know that this was 10 square. We will go ahead and write it. This is 12 square. And as we know the formula for 12 square, the answer for 12 square is nothing but 144. 1, 4 and 4. This is your final answer for the third question. The first sum which says sum of first 5 odd numbers is 5 square, 25. Second question says first 10 odd numbers, the sum is 10 square, which is 100. And the third question which says there are 12 odd numbers. 12 odd numbers, when you add them, you will have the sum of n odd numbers as n square, which is 144. In short, suppose there are 20 odd numbers. If we say we have the first 20 odd numbers, the sum of those first 20 odd numbers would be 20 squared, which is nothing but 400. So long, so forth. As we go ahead, we can proceed in the same manner for n number of odd numbers. So my dear friends, this was the summation of the first 7 questions of the exercise 5.1. In today's lecture, we have done the solutions for the exercise 5.1, question number 6 and 7. In the next lecture, we shall finish this exercise 5.1 and solve the question number 8 and 9 all in detail. So keep rocking, keep smiling, and do give me your support with a wonderful thumbs up. Also, do not forget to subscribe my channel and also share these videos with your friends so that they too are able to have a wonderful, memorable, fantastic time with mathematics. That's all for today. Have a wonderful weekend ahead. Hasta la vista. Ciao. Bye-bye.